Welcome to Month 1 of the QA Engineer track at Bistec Hearts Academy. Today we are going to learn the craft that makes or breaks software quality, systematic manual testing. This is where every great QA engineer starts. In 2014, a major airline's booking system had a bug where discount codes applied twice during checkout. It was live for 3 days before anyone reported it. Customers booked flights for nearly nothing. A single QA engineer testing the checkout flow with discount codes would have caught that in 10 minutes. That is the power of what you are learning today. Every software team needs QA engineers who can think systematically, design thorough tests, and communicate defects clearly. The skills you learn today, test design, structured execution, and professional defect reporting, are the same skills used by QA engineers at every level, from junior to principal. Let us look at how today is structured. We have 4 major blocks. First, a focused theory section covering test design techniques, equivalence partitioning, boundary value analysis, and decision tables. These are your primary tools as a QA engineer. Then we move into a hands-on challenge with the Showpeasy e-commerce platform, where you will test 4 modules and find 10 intentional bugs. The goal is 30 or more structured test cases and complete defect reports with traceability. The 10 planted bugs range from obvious to subtle. Some are in the happy path, some hide in edge cases. Your job is detective work, systematic, thorough, and methodical. By the end of today, you will have hands-on experience designing test cases using professional techniques, executing them against a real application, finding bugs, and writing defect reports that developers can act on immediately. Traceability means every test case traces back to a requirement, and every requirement has at least one test case covering it. No gaps. That is how we prove coverage. Today's 5 learning objectives are the foundation of your QA career. Let us make each one concrete. First, applying test design techniques. Equivalence partitioning and boundary value analysis are how experienced QA engineers decide what to test. When you have a registration form with 20 fields, you cannot test every possible combination. These techniques tell you which values to pick so you get maximum bug-finding power with minimum test cases. Decision tables handle the complex interactions. When a discount code interacts with a membership level and a shipping option, that is where decision tables shine. Second, writing effective test cases. A test case is only effective if someone else can execute it and get the same result. We need clear preconditions, numbered steps, and specific expected results. Saying verify the page looks correct is not a test case. That is a wish. We write test cases with measurable, verifiable expected results. Third, executing manual tests systematically. Manual testing is not clicking around randomly hoping to find something. It is following a structured process. Execute, observe, compare, document. Every single time. The discipline of systematic execution is what separates a QA professional from someone who just uses the app. Fourth, reporting defects with actionable information. Your bug report is your most valuable output as a QA engineer. A great bug report gets fixed fast. A bad bug report gets sent back for clarification, wastes time, and frustrates developers. Today, you will learn to write bug reports that developers can act on immediately. Fifth, creating requirements traceability. This is how you answer the question every project manager will ask. Are we done testing? If your traceability matrix shows green across every requirement, you can say yes with confidence. Before we get into the techniques, let us cover the foundations. These 7 principles come from the ISTQB foundation level syllabus, and they are the bedrock of everything we do as testers. Principle 1. Testing shows the presence of defects. Testing can prove that bugs exist, but it can never prove that bugs do not exist. Even if all your tests pass, that does not mean the software is perfect. It means those specific scenarios work. If all 100 of your test cases pass, it means those 100 scenarios work. There could be 100 more you did not think of. Principle 2. Exhaustive testing is impossible. A simple login form with a username field that accepts up to 50 characters has more possible inputs than atoms in the universe. You cannot test them all. This is exactly why we need test design techniques to pick the right inputs intelligently. Principle 3. Early testing saves time and money. A bug found during requirements review costs almost nothing to fix. The same bug found in production can cost thousands. Shift left. Test as early as possible. Review requirements, review designs. Do not wait until the code is deployed. Principle 4. Defects cluster together. In most applications, 80% of bugs are found in 20% of the modules. This is the Pareto principle applied to testing. When you find one bug in a module, look harder. There are probably more nearby. Principle 5. Beware of the pesticide paradox. If you run the same tests over and over, they stop finding new bugs. Just like pesticide, insects develop resistance. If your regression tests have not found a new bug in 6 months, update them. Add new scenarios, update for new features, think of new edge cases. The absence of new bugs probably means your tests are stale, not that the software is perfect. Principle 6. Testing is context dependent. How you test a medical device is very different from how you test a social media app. The risks, the standards, the approach, everything changes based on context. An e-commerce checkout needs different rigor than a settings page. Principle 7. Absence of errors is a fallacy. Software can be bug-free and still useless. If it does not solve the user's problem or meet business requirements, a zero defect count means nothing. Testing must verify that the right thing was built, not just that it was built correctly. One important distinction, while we are on fundamentals. Testing is executing software to find defects. Debugging is what developers do to find and fix the root cause. Quality assurance is the broader process, reviews, standards, process improvement, that prevents defects from being introduced in the first place. As QA engineers, you do more than just test. You are part of the quality assurance process. There are 4 levels of testing, and each one catches different types of problems. Think of these as layers in a pyramid. At the bottom, the widest layer is unit testing, individual functions and methods. A developer writes a unit test to check that a calculate discount function returns the right value for a 10% coupon. Fast, isolated, and there are hundreds of them. As QA engineers, you typically do not write these. Developers do. But you should understand them because they affect what reaches you. The next level is integration testing. This is where components talk to each other. Does the shopping cart correctly update when the product catalog sends an item? Does the payment gateway communicate properly with the order service? Integration bugs are sneaky. Each piece works alone but fails together. A common example: adding an item to your cart from a product page, but the cart shows a different price than the product page did. System testing is your primary territory as a QA engineer. End-to-end testing of the complete system. You test the whole application as a user would: registration, browsing, adding to cart, checking out, everything connected. At the top is acceptance testing. This validates against business requirements. Does the system do what the business asked for? This often involves stakeholders or product owners. User acceptance testing, or UAT, is the final gate before release. 2 common approaches to structuring these levels are the V model and Agile. The V model maps each development phase to a test level, requirements map to acceptance tests, design maps to integration tests. It is structured and clear. In Agile, testing is continuous. You test within each sprint, alongside development. Both models are valid, and most real-world teams use a blend. In your projects at Bistec, you will likely work in agile sprints, where testing happens continuously. This section covers the most important set of tools in today's session. These 5 techniques are how you decide what to test. Master these and you will design better tests than people with 10 years of experience who rely on intuition alone. Equivalence partitioning divides your input space into groups, where every value in the group should behave the same way, then tests one value from each group. Take an age field that accepts values from 18 to 120. You have 3 partitions: invalid low for anything below 18, valid for 18 through 120, and invalid high for anything above 120. Instead of testing every number from 1 to 200, you test one from each partition, say 10, 50, and 150. 3 tests instead of 200, and you cover all the meaningful behaviors. If you have a text field that accepts 1 to 255 characters, you have 3 equivalence partitions. Empty or 0 characters, valid range of 1 to 255, and too long at 256 or more. Boundary value analysis works on a key insight. Bugs love boundaries. If a field accepts 18 to 120, the bugs are almost always at 17, 18, 119, and 120, not at 55. BVA says. A says, test the boundaries and the values immediately adjacent to them. For our age field, test 17, 18, 19, 119, 120, and 121. 6 values. These 6 tests will catch more bugs than 50 random values in the middle of the range. Equivalence partitioning and boundary value analysis work together. EP tells you which groups to test. BVA tells you to focus on the edges of those groups. Always use both. Decision tables handle situations where multiple conditions interact. Imagine a discount system. Members get 10% off. Orders over $100 get free shipping, and these can combine. A decision table lays out every combination of conditions and the expected action for each. It is systematic. No missed combinations. State transition testing applies when a feature has states. An order goes from pending to confirmed to shipped to delivered. State transition testing verifies that each transition works correctly and that invalid transitions are blocked. You should not be able to go from delivered back to pending. Use case testing derives from user scenarios. The main flow: user logs in, searches for a product, adds to cart, checks out. Then the alternate flows. What if the user enters the wrong password? What if the product is out of stock? What if payment fails? For input fields, start with EP and BVA. For business rules with multiple conditions, use decision tables. For workflows, use use case testing. Now the hands-on work begins. ShowPC is a beta e-commerce platform that needs your help. The development team has built it, and they think it is ready. There are 10 intentional bugs hiding in 4 modules. Your mission is to find them all. This is exactly how real testing engagements start. You have just joined a QA team, and the product manager says, "We need to ship this next week. Can you test it?" User management covers registration, login, profile updates, password reset, and session handling. This is the foundation. If users cannot sign up or log in, nothing else matters. Think about edge cases. What happens with special characters in names? What about passwords that are too short? What about session timeout? Product catalog covers search, filtering, sorting, product details, categories, and pagination. This is where users spend most of their time. Does sorting work correctly for price, name, and date? Does pagination handle the last page correctly? Shopping cart covers adding and removing items, quantity updates, price calculations, and cart persistence. Math bugs live here. Does the total update when you change quantity? What happens if you add the same item twice? Does the cart survive a page refresh? Checkout covers payment processing, order confirmation, shipping options, and discount codes. This is the highest risk module. Money is changing hands. A bug here directly costs real money. Discount codes are a classic source of bugs. What if you apply two codes? What about an expired code? Part 1 is test planning. We are using the IEEE 1829 template structure. IEEE 829 is the international standard for test documentation. Knowing its structure gives your test plans professional credibility. The introduction section is 1 or 2 sentences. What is the purpose of this test plan? What is the scope? For ShowPC, the purpose is to verify the 4 modules before the beta release. Test items lists every feature and module you are testing, not just user management, but registration form validation, login authentication, password reset flow, profile update fields, and session timeout behavior. Test approach states which techniques you will use explicitly, equivalence partitioning for input fields, boundary value analysis for numeric ranges, decision tables for discount code interactions, use case testing for the end-to-end checkout flow. Entry and exit criteria define when testing starts and when it is complete. Entry criteria. The application is deployed and accessible. Test data is available. All modules are feature complete. Exit criteria. All test cases executed. All critical defects reported. Traceability matrix complete. Exit criteria matter because without them, testing never ends. You can always think of one more test. Exit criteria tell you when you are done. Test deliverables lists your test plan, test cases, execution logs, defect reports, and traceability matrix. List them explicitly so everyone knows what to expect. Risks and mitigations cover what could go wrong. The environment might be unstable. Test data might be incomplete. Time might be limited. For each risk, have a mitigation. If the environment is unstable, have the developer on standby. Part 2 is the core of today's work, designing 30 or more test cases across 4 modules. This is where the techniques from the theory section become practical. Let us use the age field example to see EP and BVA working together. The age field accepts values from 18 to 120. First, EP, 3 partitions. Values below 18 are invalid low. Values from 18 to 120 are valid. Values above 120 are invalid high. Then BVI. At each boundary, test the value on the boundary and the values immediately before and after. So test 17, 18, 19 at the low boundary and 119, 120, 121 at the high boundary. Then the special cases, 0, -1, empty field, non-numeric input like ABC, and decimal values like 25.5. These are the inputs that developers often forget to handle. Apply this same thinking to every input field in ShowPC. The registration form has an email field, a password field, a name field. Each one gets this treatment. Every test case needs these fields. The ID follows a convention, TC for test case, then the module code like UM for user management, then a number, TCUM1001. This makes test cases easy to search and reference. The title should be descriptive. Not test login, but verify login with valid email and password redirects to dashboard. Someone should understand what the test does from the title alone. Precondition states what must be true before you start. User account exists with email test@example.com and password securepass123. Without this, the test is unrepeatable. Steps are numbered. Each step is one action. Step 1. Navigate to login page. Step 2. Enter test@example.com in email field. Step 3. Enter securepass123 in password field. Step 4. Click Login button. One action per step. Never combine actions. Expected result is specific and measurable. Not user is logged in, but user is redirected to dashboard. welcome message displays username, and session cookie is created. 8 test cases per module is the minimum. That gets you to 32 total. But user management alone has registration, login, password reset, profile update, and session handling. 8 test cases barely scratches the surface. In a real project, a thorough QA engineer would write 50 to 100 test cases for a checkout module alone. Aim for at least 10 per module. Part 3 is execution, taking the test cases you designed and running them against the live ShowPC application. Step 1. Follow your steps exactly as written. Do not improvise, do not skip steps, do not take shortcuts. If your test case says navigate to the login page, navigate to the login page. Do not use a saved bookmark. The discipline of exact execution is what makes your results trustworthy. If you deviate and find a bug, you cannot tell whether the bug was caused by the scenario you wrote or by the shortcut you took. Exact execution equals reproducible results. Step 2. Document actual results. Write down exactly what happened. Not login failed, but clicked login button, error message displayed, invalid credentials, user remained on login page, no redirect occurred. Be specific enough that someone reading your notes can see what you saw. Step 3. Mark pass, fail, or blocked. Pass means actual matches expected. Fail means they do not match. Blocked means you could not execute the test. Maybe a prerequisite was not met. Maybe the environment was down. Blocked is not a failure. It is a flag that something prevented testing. Step 4. Capture evidence. Screenshots for every failure. Every single one. A bug report without a screenshot is like a crime report without evidence. Also capture error messages from the browser console, network responses, and any log output. The more evidence you provide, the faster the developer can fix the bug. Step 5. Note observations. Sometimes you notice something that is not a failure but is worth noting. The page loaded slowly. The button text is truncated on a smaller screen. The placeholder text has a typo. Write these down. They may not be bugs in your current test scope, but they are valuable observations. Use an execution log format for every test case you execute. Test case ID links back to your test case suite. Status shows the result. Defect ID links to your bug report if the test failed. Evidence links to your screenshots. This is how you maintain traceability. Everything is connected. Part 4 is where your value as a QA engineer becomes most visible. A well-written defect report is the single most impactful artifact you produce. The defect ID is a unique identifier, BUG of 1, BUGs and 2, and so on. In real projects, this is auto-generated by your bug tracking tool, such as Azure DevOps, Jira, or Bugzilla. The summary is the most important line of the bug report. It should be a clear, concise sentence that tells the developer exactly what is wrong. Not login does not work. Instead, login with valid credentials returns 500 error when email contains a plus sign. Specific, actionable. A developer should read the summary and immediately know what area of code to investigate. Compare these two summaries. Checkout broken versus applying expired discount code returns 200 OK and applies the discount instead of showing error message. The second one tells the developer exactly what happened, where it happened, and what the expected behavior should be. Steps to reproduce follow the same numbered format as your test case steps. A developer should be able to follow these steps, starting from a clean state, and see exactly the same bug. Include the exact data you used. If you entered test+user@example.com as the email, write that exact string. Reproducibility is everything. Expected result is what should have happened according to the requirements or reasonable user expectation. Actual result is what actually happened, stated factually, not emotionally. Not, it crashed horribly, but application displayed a 500 internal server error page, no user-friendly error message shown. Environment includes browser name and version, operating system, and screen resolution if relevant. A bug that only appears in Safari on macOS is very different from a bug that appears everywhere. Help the developer narrow down the cause. Attachments include screenshots, screen recordings, console logs, and network traces. The more context you provide, the less back and forth is needed. Severity is about the technical impact of the bug, not the business urgency to fix it. That is priority, and it is a separate concept. Critical means system crash, data loss, security vulnerability, no workaround. For example, clicking Confirm Order causes the application to crash and the user's cart data is lost. Or a SQL injection vulnerability in the search field. High means a major feature is broken, but there is a difficult workaround. For example, the Add to Cart button does not work on the product detail page, but users can add items from the search results page. Medium means a feature partially works with an easy workaround. For example, sorting by price in the product catalog sorts alphabetically instead of numerically, 125 instead of 52100. Low means cosmetic issues, typos, or minor UI inconsistencies. For example, the footer says Copyright 2024 instead of Copyright 2025 does not affect functionality at all. Severity depends on context. If a customer cannot complete checkout on mobile devices, but desktop works fine, the severity depends on your user base. If 60% of your traffic is mobile, this is critical. If 5% is mobile, it might be high. Context matters. Remember testing principle 6. The final hour is for presenting your work, learning from each other, and reflecting on the process. During the test case review, each person or pair walks through their test plan approach first, which modules you prioritized, which techniques you used most. Then show a few of your best test cases and explain why you designed them the way you did. Finally, walk through your traceability matrix, how you map test cases to requirements. When someone else is presenting, listen for things you missed. Did they test a scenario you did not think of? Did they use a technique differently? Peer learning is powerful, and good review questions are specific and constructive. Not, that looks fine, but, I noticed you did not test what happens when the user leaves the password field empty. Did you consider that? During the defect review, present your discovered defects. Show the severity rating you assigned and walk through your reproduction steps live. Actually demonstrate the bug on the application. This is a critical QA skill. Demonstrating a defect to stakeholders clearly and confidently. Then discuss your triage approach. If you found 10 bugs, which 5 should the developer fix first, and why? This is where severity and priority come together. The retrospective uses 3 columns: what went well, what was challenging, and key lessons learned. Be honest. If test planning took too long and you rushed execution, say so. If you found that BVA caught more bugs than EP, share that insight. The retrospective is how we improve as testers. There are 5 deliverables, each serving a distinct purpose. The test plan document follows IE 829 format. This shows that you can think strategically about testing, not just execute individual tests. It should include your scope, approach, entry and exit criteria, and risk assessment. The test case suite contains at least 30 structured test cases across the 4 modules. Each one with a proper ID, descriptive title, preconditions, numbered steps, and specific expected results. Quality matters more than quantity, but you need both. The defect reports are complete bug reports for every defect you found. There are 10 planted bugs, so if you found all 10, you should have 10 reports. If you found additional issues beyond the planted bugs, report those too. The traceability matrix maps requirements to test cases. Every requirement should have at least one test case. Every test case should trace back to a requirement. This is how you prove that your testing covers the scope. The test execution summary is your execution log with pass or fail results and evidence. This is the record that proves you actually ran the tests and documented the outcomes. Here is exactly how your work will be evaluated, with no hidden criteria. Test case quality accounts for 25% of the score, tied for the largest category. Quality means clear preconditions, specific steps, measurable expected results, proper use of test design techniques, and consistent formatting. A test case that specifies the exact input data, the exact steps, and the exact expected behavior gets full marks. Test coverage accounts for 20%. Did you test all 4 modules? Did you cover positive and negative scenarios? Did you test happy paths and edge cases? Coverage means breadth. How much of the application's functionality did your tests touch? Defect reporting also accounts for 25%. Are your bug reports reproducible? Do they have clear severity classifications? Is the evidence sufficient? Can a developer who has never seen the application reproduce the bug from your report alone? That is the gold standard. Test design techniques accounts for 15%. Did you apply EPBVA and decision tables? If you test an age field with values 17, 18, 19, 1919, 120, and 121, that is clearly BVA. Show your work. Documentation accounts for 10%. Is your test plan complete? Are your documents well organized? Is the language clear and professional? Consistency in formatting and naming conventions matters. Traceability accounts for 5%. Does your traceability matrix exist? Is it complete? Does every requirement have at least one test case? And does every test case trace to a requirement? A passing score is 70, and 85 or above is excellence. 70 is achievable for everyone who applies what they have learned today. 85 is for those who go the extra mile. More thorough test cases, better bug reports, additional scenarios beyond the minimum. These are your growth activities between now and month 2. Each one builds your skills as a QA professional. Study the ISTQB Foundation Level Syllabus, Chapters 1 through 3. ISTQB is the most widely recognized QA certification in the industry. The foundation level certification tells employers that you understand testing fundamentals at a professional standard. Chapters 1 through 3 cover the same principles from today, but in much more depth. This is an investment in your career. Write 50 additional test cases for a personal or work project. Practice makes permanent. Pick any application you use daily, a banking app, a food delivery app, your company's internal tool, and apply EP and BVA to every input field. You will reach 50 faster than you think. Explore 3 bug tracking tools: Azure DevOps, Jira, and Bugzilla. Get hands-on with the tools real teams use. Azure DevOps has excellent test management built in. Jira with plugins like Zephyr is the most common combination in the industry. Bugzilla is open source and great for learning. In month 2, you will use these tools in your workflow. Document 5 real bugs found in any application. Be a QA engineer in your daily life. When you find a bug in an app you use, write a full bug report for it using today's template. This builds muscle memory for professional defect reporting. Read Agile Testing by Lisa Crispin, Chapters 1 through 4. This book changed how the industry thinks about QA in agile teams. It will help you understand how testing fits into sprints, how QA engineers collaborate with developers, and why the whole team is responsible for quality. Create a reusable testing checklist template for web applications. Include common categories: form validation, authentication, navigation, error handling, responsiveness, accessibility, and performance. This becomes your personal QA toolkit. Here are your essential resources to bookmark for the track. For reading, the ISTQB Foundation Level Syllabus is available for free download at ISTQB.org. This is the foundation of your professional knowledge. Software Testing Fundamentals at softwaretestingfundamentals.com is an excellent reference site with clear explanations and examples covering every technique from today. Agile Testing by Lisa Crispin and Janet Gregory is the definitive book on QA in Agile teams. The IEEE 8-29 standard is the test documentation reference we used for the test plan structure. For tools, Jira is the most widely used bug tracking tool in the industry. Create a free Atlassian account and start exploring. For test management, look at TestRail, Zephyr for Jira, or KeyTest. These tools let you organize test cases, track execution, and generate reports. Excel or Google Sheets are perfectly fine for test case management when you are starting out. Many professional QA teams still use spreadsheets for test matrices and traceability. For screenshot capture, Snipping tool comes built into Windows, and macOS has built-in screenshot tools. Lightshot is a free third-party tool that adds annotation features such as arrows, text boxes, and highlighting. Let us look at how today's time was structured. 60 minutes of introduction and theory, 120 minutes of hands-on challenge work, and 60 minutes of review and presentations. This 2-hour theory, 2-hour practice ratio is intentional. We believe in learning by doing. You walked in here this morning as someone interested in QA. You are walking out as someone who has designed test cases using professional techniques, executed them against a real application, found real bugs, and written professional defect reports. That is not trivial. That is the foundation of a QA career. In month 2, we will build on everything you learned today. We will introduce test automation, explore API testing, and work with industry-standard tools. The fundamentals you built today make all of that possible. Remember, testing is detective work. Every bug you find protects users. Every clear defect report you write saves developer hours. Every thorough test plan you create builds trust in the team. You are not just checking boxes, you are safeguarding quality. Be proud of that. Thank you for your focus and energy today. Keep practicing, keep exploring, and we will see you in month 2.